We will continue with the functions, the chapter section 3.3. Functions are prevalent in Rust code. You've already seen one of the most important functions in the language, the main function, which is the entry point of many programs. You've also seen the fn keyword, which allows you to declare new functions. Rust code uses snake case as the conventional style for function and variable names, in which all letters are lowercase and underscores separate words. Here's a program that contains an example function definition. We've got the main function, which prints hello world and calls the function named another function. Another function is defined here after the main function, which separates how C parses the code, which prints to stdout the another function string. We define a function in Rust by entering fn followed by a function name and a set of parentheses. The curly brackets tell the compiler where the function body begins and ends. We can call any function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. Note that we defined another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions, only that they're defined somewhere in a scope that can be seen by the caller. Let's start a new binary project named functions to explore functions further. Place the another function example in rs in source main.rs and run it. You should see the following output. The lines execute in the order in which they appear in the main function. First the hello world string, message prints, and then another function is called and this message is printed. Okay. The parameters. We can define functions to have parameters which are special variables that are part of a function's signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the words parameter and argument interchangeably for either the variables in a function's definition or the concrete values passed in when you call a function. In this version of another function, we add a parameter. Okay, so here is the definition of another function, which now takes a single variable named x of type i32. The main function calls the another function with x equals 5 and prints it to stdout. Here, after trying to run the program, we should get the following output. Here is the output, which is indeed x is equals to 5. The declaration of another function has one parameter named x. The type of x is specified as i32. When we pass 5 into another function, the println exclamation point macro puts 5 where The pair of curly brackets containing x was in the format string. In function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust design. Requiring type annotations in function definitions means the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful error messages if it knows what types the function expects. When defining multiple parameters, separate the parameter declarations with commas like this. Here, the main function calls the function print labeled measurement with two parameters, two arguments, 5 and h. It is defined as such. The first argument is of type i32, whereas the second is of type char. Okay, so value is 5 and unit label is h. So we should see the string, the measurement is colon, and then 5 followed by the character h, which is what we get here. This example creates a function named print labeled measurement with two parameters. The first parameter is named value and is an i32 type. The second is named unit label and this type is char. The function then prints text containing both the value and the unit label. Try running this code. Replace the program currently in your functions project src main file with the preceding example and run it using cargo run. Because we called the function with 5 as the value for value and h as the value for unit label, the program output contains those values. Okay. Statements and expressions. Function bodies are made up of a series of statements, optionally ending with an expression. So far, the functions we've covered haven't included an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinctions. So let's look at what statements and expressions are and how their differences affect the bodies of functions. Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resultant value. Let's look at some examples. We've actually already used statements and expressions. Creating a variable and assigning a value to it with the let keyword is a statement. In listing 3.1, let is a statement. Okay, so this is a statement. It has no return value and performs an action. It does not evaluate to a resultant value. Function definitions are also statements. The entire preceding example is a statement in itself. As we'll see shortly, calling a function is not a statement though. Indeed, because it returns the function's return value. If the function returns 5, then if you call a function, the instruction which calls the function is an expression because it evaluates to a resultant value. It also, however, performs an action, some action, some actions. A function performs some actions, but also has a resultant value. Function definitions are also statements. Yeah, we read though. Statements do not return values. Therefore, you can't assign a let statement to another variable, as the following code tries to do. You'll get an error. Here, we attempt to initialize x variable with the resultant a value of this statement. Since it is a statement, and statements do not have return values, this is an error. When you run this program, the error you'll get looks like this. Only supported directly in conditions of if and while expressions. Okay. Here, this cannot compile. So this is a correction, maybe? Hello, I'm from the future. So this isn't the correction. It's the compiler pattern matching against the fact that we have parentheses inside the hypothetical expression that we've written inside them. So it suggests that we remove them, but also it errors for the fact that the keyword let is inside the expression. So it errors, it's a warning, the parenthesis is a warning, but the let keyword is an error. So it's just a pattern match. If we attempt to compile, you can see here the previous compilation attempt. It's the exact same here. So there's an error. It says that it expects an expression, but it found the let statement. So that's a statement here, and not an expression, and therefore it errors, and the parenthesis is a warning. So the note here is not a correction. This isn't a correction. It's a to resolve the warning. Remove this line and add this one. The let y equals 6 statement does not return a value, so there isn't anything for x to bind to. This is different from what happens in other languages, such as C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals 6 and have both x and y have the value 6. This is not the case in Rust. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of statements. In listing 3.1, the 6 is the statement. The 6 in the statement is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly brackets is an expression. For example, here inside the function main, we declare a new variable y, which has here x. Y will have the value returned by this expression, because a new scope block created with curly brackets is an expression. And I can infer from here, this is the value returned, probably. So the value returned with which also y is initialized should be 4. So here, this is 4 should be printed in here in the format string. This expression is a block that in this case evaluates to 4. Yeah. So x is 3 plus 1 is 4. And here, this is the return statement. The implicit, semantically similar to what a return statement would do in C, inside the function. But here we don't have a function exactly. It's like an anonymous function without a name, and probably it can capture the surrounding scopes, the surrounding scope, the proceeding actually. So here we probably inside here we could reference the same variables that can be referenced in main's scope, but before this body opens. I speculate. Okay, so it evaluates to 4. The value gets bound to y as part of the late statement. So statements do something and don't have a value, a return value. Expressions do have a return value. Note the x plus 1 line without a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement, and it will then not return a value. Keep this in mind as you explore function return values and expressions next. Okay, so then functions with return values. It would be cool if this here is equal semantically to the return x plus 1 semicolon. If we added a return here before the x plus 1 and a semicolon afterwards as a trailing character of this line, it could be semantically the same. All right. Functions with return values. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. All right. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of the function. The final expression, the value of the final expression. Here we define a function named 5 with no parameters. It returns an i32 type, and here we implicitly return 5 from this function. Inside main function, we bind x to the value returned by the expression which calls the function 5. And then we print the value of x, which should be 5. There are no function calls, macros, or even let statements in the 5 function. just the number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified too, as arrow right direction, arrow pointing to the right, I32. Try running this code. The output should look like this. Here we run the code, yeah, so it's 5, which is consistent with what we speculated. The 5 in 5 is the function's return value, which is why the return type is I32. Let's examine this in more detail. There are two important bits. First, the line let x equals 5 shows that we are using the return value of a function to initialize a variable. Because the function 5 returns a 5, that line is the same as the following. Second, the 5 function has no parameters and defines the type of the return value, but the body of the function is a lonely 5 with no semicolon, because it is an expression whose value we want to return. Let's look at another example. We have a function named +1, takes a variable of type I32 named x and returns an I32 type. This is the return value, which should be one more x plus 1. Running this code will print the value of x, and also in the main function we initialize x with the value returned by the expression here, which expression calls function with 5 as the argument. So 5 is increased by 1, so x should be 6. Yeah. But what happens if we place a semicolon at the end of the line containing x plus 1, changing it from an expression to a statement? Okay, let me speculate. In previous chapter, we read a small paragraph which stated that all expressions must return something, and if they return nothing, then the empty tuple is returned. Let's see. Here the only changed part is the instruction of the +1 function. We converted it to a statement. Compiling this code will produce an error as follows. Yeah, the empty tuple isn't of type I32. But here, look what the error is saying. Mismatched types. I was 50% correct. Implicitly returns an empty tuple as its body has no tail or return expression. No tail expression or return expression. Here is the help. Remove this semicolon to return this value. This here would add to the function's body a trailing expression. Okay. The main error message, mismatch types, reveals the core issue with this code. The definition of the function plus 1 says that it will return an I32, but statements don't evaluate to a value, which is expressed by the unit type. Therefore, nothing is returned, which contradicts the function's definition and results in an error. In this output, Rust provides a message to possibly help rectify this issue. It suggests removing the semicolon, which would fix the error. Alright. So question number 1. How do we specify what kind of type is the unit type? If we added the unit type as the return type here, would that be correct? Let's see the data types. And this is a compound type. It is a tuple. Yeah, I think if here nothing is inside, so we have a tuple with no elements, then we could initialize this tuple with no values. Let's see here what the tuple without any values has a special name, unit. This value and its corresponding type are both written, here. The value and its corresponding type are both written as and represent an empty value or an empty return type. Expressions implicitly return the unit value if they don't return any other value. So this is the answer. Let's run it. Attempt to create a function. Rust cores. Here we have 3 Rust 3 and we want to copy this, and here this function should return an empty tuple, and then we attempt to print the empty tuple. This here should be of type of this type, the unit type. Here this is gargleless. It's excess because we already have specified the type of x implicitly using the return value of the function. But to be more explicit and lock down our assumption that this here is correct Rust code, I added the type. So let's compile. Here, all right, cannot be formatted. The unit type cannot be formatted with the default formatter. The trait is not implemented for the unit type. In format strings, you may be able to use instead. Okay. Expansion macro. Okay, so maybe, but we just saw that it didn't fail because of our return type or because we specify the type of x to be the unit type, but because What was the error again? Yeah, well, because of the print, we cannot print the empty tuple. So let's try to use this here. Maybe, yeah, I like if it was possible to print, when you print a tuple, to be replaced by a tuple, and inside, if the tuple has a number, to be like this. So here, it would be cool if this would be replaced in this specific case with the empty, with the unit type, the unit value. All right. Let's add, how can I make this work? Okay, so what's up with this? This here, semicolon question mark. Let's add that. Symbol question mark. Let's see what this does. One positional argument in format string, but no arguments were given. If this is intentional, prefix it with an underscore and use the variable x. All right. Okay, so let's add the variable maybe after x or before. Let's add the x here. This here makes more sense. It's more possible because x colon question mark. This is a special character followed by a normal character. This here would be, but we will try both. Unused arithmetic operation that must be used. The arithmetic operation produces a value, but this is also a warning. All right, so it did compile. Yeah, so here we got what I wanted. Let's try to place the x after and see what happens. Expected, okay, so it says that x should be between the semicolon and question mark. X here. We have one positional argument in the format string, but no arguments were given. Here, I think that I assumed the semantics of this is that the provided value is x, but maybe it's not. And then a warning about the unused variable. Okay, let's go ahead and if I add the x also at the front and in between, here this runs, and then it's, by the way, I attempted to run it with Valgrind and it's possible. Here it says that 544 bytes in one blocks are licked. Maybe they are being licked because the program is very small and it does not, this is not a true memory leak because there's no loops at all. It's just a straight up add 1 to 5 and print the value.